Hey guys, and welcome to this video on a proof by contraposition. So here we want to prove that if n squared is even, then n is even. And if you recall that a conditional proposition like P implies Q is logically equivalent to not Q implies not P. Okay, and so our P in this case is saying that n squared is even, and our Q in this case is saying that n is even. And we can read this as n squared is even implies n is even is logically equivalent to not Q. So let's figure out what not Q is. Implies not P. So not Q is saying that n is not even. So n is not even. And so if n is not even, the only thing it can be is odd. So that means that n is an odd number. And so what is our not P? Let me rewrite that P there to make it look a little bit better. Okay, so our not P is saying that n squared is not even, which is stating that n squared is odd. Because again, if it's not even, then it's odd. All right. So let's consider the contraposition of this statement. And we want to show that if n is odd, then n squared is odd. So let me change my marker. To do this proof here, we want to show the contraposition. So show the contraposition that if n is odd, then n squared is odd. Okay, and that's exactly what this is here. So this is basically saying that if n is odd, then n squared is odd. And so that's exactly what we're doing here. So I hope you guys can see that and understand that. So let's assume here, we're going to assume that n is an odd number. Okay. And we'll say n is an, let me see, assume n is, I'm going to put an odd integer. An odd integer. Okay. So n is odd. That means that we get n is equal to 2 times q plus 1, where q is some arbitrary integer. Okay, and I'm not going to keep writing this over and over again, but just remember that q is an integer value. All right, so now if we square both sides, we get n squared is equal to 2 times q plus 1 squared. And again, q is just some arbitrary integer value. And let's go ahead and write that out. So now n squared is equal to, let's see, 2q times 2q is 4q squared, plus, let's see, we're going to get 4q plus 1. All right. Now what I'm going to do is I'm going to pull out a factor of 2 here. So we're going to have 2 times 2q squared plus 2q plus 1. All right. And again, q is still some arbitrary integer value. So this means that n squared is equal to 2 times, I'm going to call all this right here q1. So q subscript 1 plus 1. And so now I'm going to write where q1 is some integer value. Okay. All right. So this right here implies that n squared is an odd number And having used a direct proof to show the contraposition of the proposition, we conclude that if n squared is even, then n is even. So maybe I'll put that down here. Having used a direct proof to show the contraposition of the proposition, we conclude that if n squared is even, then n is even. Okay. So thank you guys. That's basically it. I hope you enjoyed the video. I hope I explained it very well. Please leave any questions you have in the comments section. Don't forget to subscribe and leave likes. And if you enjoyed this video and think it'll be helpful for others, please share it. And as always, guys, thanks for watching, and I'll see you all in the next video.